to find the part that we're missing. So their triangle is kind of crazy. I don't even know. Maybe kind of like this. Okay. And then we know the actual distance here, which is the height, is x. So we don't really know it. And we don't know this either. Okay, let's see what they gave us. The base of a triangle in which the area is x squared. So with this ones, remember we put the formula. Base times height divided by 2. Lots of people do base times height times 1/2. It's the same thing as dividing by 2. Either way, you'll get the same answer. So just do it whichever way is comfortable for you. Base times height divided by 2 equals the area. We know the area is x squared. Okay. Do we know the base? We know the height is x. I guess we could put that. So we have something weird and crazy like this, right? Okay. So we're going to need to solve this thing. So the first thing, well, I'm doing it totally. They're multiplying by 1/2, but that's okay. We can get there as well. Let's do by 1/2, so we're doing the same thing that they're doing. That's fine. We can do it that way. Okay. So I'm trying to get to this b, so I need to get rid of this x. So I'm going to divide by x here. I'm going to divide by x here, right? 1/2 b would be what I have left on this side. And what's x squared divided by x? X. Because you have x squared up here, right? And one of them below. And so when you divide, you just have 1. Okay. So now we need to get rid of that 1/2, correct? And how do you get rid of a 1/2 to move it to the other side? Okay, good. You multiply by 2. So you multiply by 2, multiply by 2. So 2x would equal b. Is b what we were looking for? Yes, we were looking for the base. I know it's not an actual number answer, but it is an answer. So we're going to write it and we're going to label it inches because it's just the length of here. It's not the area or anything. Okay. Example number C would be the same thing. We would just have area equaling the formula and plug in everything we can and solve for what we're missing. I can do that with you if you're confused, but I don't want to make these videos too terribly long so that you don't get completely bored with me talking. Let's look at the formula for a rhombus, I think is next, maybe? Yeah, rhombus. Okay, a rhombus is a smashed square. Remember they drew theirs like this? It doesn't even look like a square at all, but that's okay. Rhombus's area is a diagonal times the other diagonal. Diagonals, remember, go from vertex across to the other vertex, okay? So diagonal 1 times diagonal 2 is what they call it, and then I divide by 2. They multiply by 1/2, same thing, okay? Kites have a similar formula, diagonal 1. This would be called a diagonal as well. So kites are there too, diagonal 1 times diagonal 2 divided by 2, same thing. So rhombuses and kites, you can get the same way. Okay. So example 3 says find each measure, diagonal 2 of a kite in which diagonal 1 is 16 and the area is 48. So we're dealing with a kite, which is this one. We know that diagonal 1 is 16, okay? And we know the area is 48. All right, so we're going to plug in what we know into our formula here. Area equals diagonal 1 times diagonal 2 divided by 2. Okay, what parts of that formula do I know? I know the area is 48. I know one of my diagonals is 16. Do I know anything else? Okay, I see there's kind of a glare there on the board. Hopefully that's not too bad. I think you can still see okay. All right. So we just need to simplify this. There's a lot of ways we can do it. We can multiply by 2 and then divide by 16, or we could just do 16 divided by 2 right now and get to 8. Whatever you want to do. When you simplify, you would get down, let's see if I do that, 8, and then I divide. 48 divided by 8 ends up being 6. So we would answer 6, and then what measurement are we using? We're using centimeters. Would I square this? No, my answer would just be 6 centimeters, not squared, because it's just the length of this diagonal right here. Okay? Awesome. Okay, on page 680, there's more examples of the same thing with rhombuses and also with kites. I want you to look at example C real quick. Example 3C. Notice in kites, often they'll do this. These are all right triangles. So you may have to do Pythagorean theorem somewhere in this right triangle to figure out a diagonal to be able to do your area formula. Okay, so these are all right triangles. Use Pythagorean theorem to get the missing legs, which are diagonals, so that you can do your formula here. Okay? All right, I think that's it. If you look on your Google Docs, you'll see the numbers for the page here, and just so you feel at home, I don't want you to feel like you're not part of what we usually do. I mean, we need to feel at home. I should throw, there, now we can feel at home. Okay, and here is your joke for the day. Photographer, what are you doing in my darkroom? Elijah, what do you think? I know you're looking through your thing, trying to find words that would fit with this joke. Photographer, what are you doing in my darkroom? Math student, I'm waiting for my formula to develop. And with that, I will leave you. Have a great day. Goodbye.